Rank these 4 molecules by the number of atoms each one has. Since this highlighted region is the same across all 4 of these molecules, we can simply ignore it because that's a distraction. R is meant to denote a long chain of carbons and hydrogens, and in this case, R is the exact same across all 4 molecules. By nature of how we illustrate organic molecules, the N's and the bens represent carbons. So let's show them. We write in the carbons and acknowledge the fact that each carbon needs to form 4 bonds with other atoms. However, it's clear that some of these carbons don't have all 4 of the bonds it needs, such as this one up here, which we only see 1 bond for, so it's 3 short. That's where the hydrogens come in. We make up for carbon's bond deficit with the correct number of hydrogens such that each carbon can have all 4 bonds. The carbon that was 3 bonds short now has all 4 bonds because those 3 bonds are now CH bonds. Now that we have our Lewis structures, we can refer back to our original question with a more thorough picture of what atoms compose molecules 1, 2, 3, and 4. And it's clear that molecule 4 has the least number of atoms, whereas molecule 1 has the most. Looking at the same molecules but in bond line form as we were given, you can see the temptation of believing the exact opposite to be true. That of being tempted to put A as the correct answer, when in reality, as we just saw, it's D. But what about when we rank the mass of these molecules? Well, we've already turned our molecules into Lewis structures, so we can see all of the atoms in the bonds present. So really, the differences between each molecule is the presence or absence of methyl groups and hydroxyl groups. So understanding what elements compose each group respectively will inform our mass comparisons. Using the values, the atomic masses on the periodic table, we calculate that a methyl weighs 15.03 atomic mass units and hydroxyl is 17.01 AMUs. In other words, a hydroxyl group weighs more, it's more massive than a methyl group. This also means that whichever molecule has the most hydroxyl and the least methyl will be the most heavy. Whereas if they are all methyls and no hydroxyls, it will minimize the mass. Thus, molecule 4 has the most mass, followed by 3, then 2, then 1 is the least massive. So if we compare the answers to both of our questions, we see that there's an opposing trend, where the least massive molecule also has the most atoms, and vice versa. But is this inverse trend with mass and atoms always the case, or at least typically? If you want to meaningfully understand the relationship between mass and matter, check out the video on your screen to ensure you have the integrated knowledge to tackle just about any molecular problem.